Hello, my name is Edward Lee. I'm from Berkeley. I'm going to be telling you about a project called Lingua Franca that is currently my favorite project. It's grown into an international collaboration. And this sequence of videos comes from a tutorial that we gave at a conference called MSoft. It is part of ES Week that was held in October of 2021. And this series of videos is a tutorial on aspects of this project that is intended to give you an overview of what Lingua Franca is and how to use it. And in particular, we hope to entice you to either contribute to this project or join it and begin to use the infrastructure that we're building. So let me start by telling you a little bit about Lingua Franca. So Lingua Franca is what we call a coordination language for building software systems with an emphasis on getting repeatable behavior with multi-core systems, distributed software, or real-time behavior, or any combination of those three things. Whenever you have concurrency and possibly real-time requirements, Lingua Franca might possibly be a very good choice. The emphasis in Lingua Franca is getting deterministic coordination, which gives you repeatable and testable behavior. So one of the key features of Lingua Franca is that it's not a programming language, it's a coordination language. So you do your work, most of your work will be done in a language that you are familiar with and have been using for your projects, and you're able to integrate legacy code. It can orchestrate legacy software components and can use existing libraries and modules. You don't have to learn a new programming language, but you do have to learn a new way to compose modules in that programming language, to define and compose those modules. And the benefit that you get from adopting this technique of defining and composing modules is you get much more disciplined and deterministic interaction between these components. So this video is the first part of a 6-part tutorial where we're going to show you how to use the Lingua Franca tools, specifically an Eclipse-based integrated development environment and a standalone command line compiler. We're also going to show you how to work some of the work that's in progress, in particular, a variety of research projects that we're working on, and how the Lingua Franca tools can be extended in various interesting ways. So to give you a quick overview of what you're going to see, in part 1, which is this video, I'm going to give a little bit of the history of the project, and then Martin Lostra will show you how to get started with the tools. So this is very hands-on. Where do you download the code? If you want to use a virtual machine to just get something that's completely pre-configured, he'll show you how to do that. Or you should be able to get our integrated development environment or our command line compiler working on any Windows, Linux, or Mac machine. And that would, if you go through that setup, you should be able to follow along with part 2 of the video, where Martin Lostra will walk through the construction of a simple Hello World Lingua Franca program. And then Alexander Schultz Rosengarten will show you some of the features, in particular the interactive visualization, which is a very powerful tool to help you understand the overall structure of your programs. So in that part of the tutorial, in this part 2, we're going to be using the C programming language as the target language. So that means that your programming logic is written in C, and the Lingua Franca compiler, which is actually a code generator, will generate standalone C programs that are then compiled and executed using standard tools like GCC. But you don't have to use C with Lingua Franca. And in part 3, I tapped several members of the development team to tell you about other target languages that we have built support for. In particular, Christian Menard will tell you about the C++ target, emphasizing how Lingua Franca dovetails very nicely with an object-oriented language and can exploit advanced features of the language, such as generics, and can leverage pre-existing libraries like the standard template library in C++. Then Sarush Pateni will show you the Python target, emphasizing how lingua franca can work with an untyped language and can exploit the rich ecosystem of Python modules. He'll show you a machine learning-based real-time image analysis application that is built using Python libraries, but orchestrated as a collection of lingua franca components. And then Stephen Wong will show you how lingua franca can integrate using very sophisticated Python libraries such as Pygame. So then Martin Lostra will show you a fourth target language, which is TypeScript, which is a strongly typed dialect of JavaScript that is widely used in web applications. And in particular, Martin Lostra will give you a simple demonstration of how you can construct a web server application and integrate that into your applications. And then finally, in that last part of the last little segment of part 3, Clément Fournier will show you his still rather preliminary, but progressing very nicely, Rust target. So Rust is a language that has, in many ways, the efficiency of C, but much stronger safety features, much stronger memory management. And he's going to emphasize how lingua franca can, in fact, exploit those features of Rust to give you much safer programs. So in part 4, in the 4th video, I will use a simple lingua franca example that's realized using the C target to explain in more detail how key features, to explain in more behavior key features of the language. And in particular, I'm going to show you how timing is specified, how external asynchronous inputs are handled, and how cyclic programs with feedback work. So I'm going to then leverage some team members to show you how a Python realization of the same program with a more advanced user interface. And then we will also show you a real-time music application that really emphasizes some of the real-time capabilities of the language. So in part 5, we show you several of the team members. We'll show you how you can build large, scalable lingua franca programs, how they can be specified compactly using a very elegant syntax, and how multi-core processors are automatically exploited, and how you can create what we call federated programs, which are lingua franca programs that distribute across machines across a network. We're also going to show you how to closely examine the performance of your application by tracing. And we're going to give you some preliminary benchmark data that shows that something that might be quite surprising, which is that lingua franca is quite competitive in performance with less deterministic alternatives that are fairly widely used for building concurrent and distributed programs. Part 6 is my favorite part of this video sequence. In part 6, team members are going to highlight a few of the research projects around lingua franca. In particular, Christian Menard will explain how lingua franca solves some of the problems that arise in adaptive AutoSAR, which is a widely used framework for automotive software, or automotive embedded software. Sarush Pateni will show you how lingua franca can replace ROS with a more deterministic interaction mechanism, and how this solves some of the problems that arise in self-driving car software. In particular, he's going to explain how he ported AutoWare.auto to lingua franca, freeing it from its dependence on ROS, and how he integrated the Carla open source adaptive automotive simulator into lingua franca. Efsane Sawyer will explain how the C target can be adapted to produce programs that run on bare iron machines with no operating system. So this shows some preliminary work that suggests that lingua franca can be used to develop some deeply embedded applications. Alexander Schultz-Rosengarten will show you extensions that he is building that support what we call modal models, which integrate finite state machines as an integral part of the way that you build programs in lingua franca. This can lead to much more understandable programs and, importantly, much more analyzable programs, which leads us then to Xiaokai Lin, who will explain some research that he is doing, how he will explain how he's integrating lingua franca with SMT-based solvers to perform formal verification of lingua franca programs. Hokan Kim will explain how he plans to integrate a security framework that he built as part of his PhD research into lingua franca in order to endow federated programs with state-of-the-art authentication, authorization, and encryption infrastructure. And finally, Peter Donovan will explain how he's building a language server that enables the use of lingua franca tools within other IDEs, such as Visual Studio Code. So just a little bit of background about this project. So the project that we're going to be talking about started in the fall of 2018 when Chris Gill from the Washington University at St. Louis and Martin Schuberl from the Technical University of Denmark happened to be visiting my group in Berkeley. And they were both coincidentally very interested in programming processors for deeply embedded applications that had very predictable timing properties. And we started brainstorming about what it would take to have a modern programming framework for that was sophisticated about concurrency and time, and started sketching out a language that was very much informed by prior work we had done in a project that we called Accessors, which was part of the Ptolemy 2 effort. And Martin Lostra, who was a PhD student of mine at the time and is now a postdoc and will be one of the lead presenters today, had some very interesting ideas about generalizing the model of computation behind accessors. And we started to understand that this model of computation was very related to, in some ways, it was drawing kind of the best of synchronous languages and discrete event systems and actors. And so we got kind of excited about the idea, and Martin Schuberl went off and within 2 days had built a very simple prototype compiler. And that got us kind of off the white page problem and got us starting to work on it. I went shortly thereafter to Dagstuhl and met up with a former student, Johan Ecker, former postdoc in my group, actually. And Johan, who is at Ericsson, suggested to me that we take a look at Xtext because of the infrastructure that it provides for very quickly building compilers. And so I started playing around with it and created a second version of the compiler using Xtext. And then we started to really run with that. Around that time, Martin connected up with Christian Menard at the Technical University of Dresden, who was a PhD student who was working on trying to solve problems with adaptive autosar. And he had come up with a model of computation that was very closely related to what we were doing. And so we kind of roped him into this project, and he became a really powerful force behind the development. In the fall of 2019, we then coincidentally went to Southampton in England to the Forum on Design Languages, the FDL conference, and there Reinhard von Hangsladen, who's a professor at Kiel University in Germany, and his students were making a presentation, and Alexander Schultz-Rosengarten, who will be presenting today, gave a presentation that made us realize that there was a tremendous synergy between what he was doing and what we were doing. And so I introduced him to Martin, and within 2 days, they had actually put together a preliminary integration of our tools, and you'll see the effect of that today. So the project has grown quite a bit. There's quite a few people involved. Another key person is Sarush Bateni, who's from the University of Texas at Dallas. And he actually sent me out of the blue an email wanting to do an internship. And I get quite a few of these, but this one was particularly sharply targeted and fit our project. And so I jumped on it and started working with Sarush, and it really took off. And he has become also another powerful force behind this project. So that's just a little bit of the background. The project has been growing. We're welcoming other participants. It's very much an open source project, BSD style license. We encourage both commercialization efforts and research efforts, and it's a tremendous source of research ideas. It seems like every meeting we have another potential PhD research topic that comes out of this. So we hope it'll be as stimulating for you. So with that, I'd like to turn it over to Martin Lostra, who is going to give you some orientation on how to get started. So this is going to be starting out with just some logistics, and take it away, Martin. So just a little bit of background. Martin was a PhD student in my group, is now a postdoc in my group at Berkeley. And yes, so Martin.
Thank you, Edward. So yes, I'll go ahead and walk everyone through the initial steps that are required to participate in this tutorial. All of these steps are also outlined here on our wiki page, which is available through esweek.lflang.org. So should you lose track of anything during this presentation, you can refer to this page. So we've basically outlined two different options to configure your system. One is actually not to configure your system at all, but to just use a pre-configured VM image that you can download. The other one is to use our nightly release and install it on your system. So when it comes to the dependencies, really the most important one is Java 11, but depending on the targets that you use in your LF code, you might also need additional dependencies. So for instance, if you write LF code that declares a C target, then our compiler invokes the C compiler in order to compile the generated source code. So in that case, you actually need a C compiler and you also need CMake. And so for the various targets, there are different sets of dependencies, and you can find these all here. If you want to make things easy, you can use the VM image that has all of these already installed. So you can just go to vm.lflang.org, and this will take you to a Google Drive that has this OVA image that you can just download and then load into your favorite VM software. So I personally use VirtualBox, but it's also compatible with VMware, for instance. Okay, I will show how to do that in a little bit, but first let us have a look at how to do the installation locally. Okay, so there's a releases page where we publish our nightly releases that have assets with them. We have two pieces of software. One is the Epoch IDE, which is our custom integrated development environment, and we have LFC, which is our command line compiler. So each of these is packaged for different platforms. So Epoch is available for Linux, Mac OS, and also Windows. And LFC is Java-based with a bunch of scripts, and we package them as a tarball or as a zip. So go ahead and download the artifacts that match your platform. And I've already done this on my system, and I have put them in a directory called ESWeek. Let me delete these. So the first step is to extract them. And now we have these two new directories. The first one is Epoch IDE. The other one is LFC Nightly. And what I'll do to simplify matters is to just copy this into the ESWeek directory that I created and just get rid of this redundant folder. And when it comes to this guy, I can just rename it. I will name it to LFC. So what we have now is a directory Epoch and a directory LFC. You can put these anywhere in your system that you'd like. I put them in my home directory /ESWeek. And in the Epoch directory, we now have this Epoch executable, which we can run. There it is. We then also have to specify our workspace. So let's call it workspace ES week, for instance, to make sure that we have a clean one. And then Epoch continues to start. The first page that you'll see is a welcome page that is not shown here because I've previously used this this workspace. But the welcome page shows the contents of our wiki, and you can just click that away, and then you'll get this screen. So if you want to execute Epoch or LFC from the command line, it's also very useful to be able to add them to the path. So we can do that. Linux distributions usually use a .profile file or a .bashrc file to specify things that need to be added to the path. So you can go ahead and see here what I did. So I exported path with added to it this home directory / ESWeek epoch directory, which is this guy. And then I also added my home directory ESWeek LFC bin, which has this bash script in it. So just to make sure that they've been sourced, we can now see if they're on our path. So we can do which LFC and which epoch, and we see that both are there. And we can also run LFC -help just to see if it responds, and it does. So that is basically it. I can now move on to the VM installation, which really is taking the downloaded VM image and importing it in the VM software. So I already did that here, and then you can run it. So the OVA image is compressed, and so it takes a little bit to uncompress it, but then you should have a virtual machine entry in your software, and then you can start that. Move this over here. Oh. Let me scale it just to make it a little bit more visible. And so as you can see here on the left-hand side, there's already our epoch icon. So you can just directly click on that, and that should launch it. There it is. And it also shows the wiki welcome page, as I mentioned earlier. And LFC is also pre-installed. Okay, so that is about it. This would also be a good time to ask questions if there are any. And if not, back to you, Edward.